Next problem, 160 intersection of two linked lists. I want to solve this problem. So basically what I should do for this problem is to find the node where those two linked lists are intersect. And I want to solve it in O of m plus n time and then O of 1 memory. And in order to do so, I'll just walk through the first list and count the number of elements in the first, and then walk through the second list and then count number of elements in the second, and then compare the difference. And then I need to, let's say in this case, I'll have the 5 elements in the linked list A, and then I have 6 elements in list linked B, and then I need to calculate the delta between length A and length B will be 1, and it means that I need to move to go one element of B forward from ahead, and then I need to sync the 2 pointers, and then I need to move simultaneously like 2 pointers until they meet. And when they meet first time, that's gonna be the result. So in this case, the space complexity gonna be, I just need to traverse the first linked list and then save the number of elements in the first linked list, then traverse the second one and save the number of length of the second linked list, and then need to traverse first until they first like walk the delta nodes, depending on like which one is longer, A or B, and then walk until they meet each other. So like in a worst case scenario, gonna be 2n, but like I can drop the constant. The time complexity gonna be eventually all of n. So that's gonna be it. So first of all, I need to figure out, okay, what's the length of the list that starts with the head A. So I'll have this, say, have def len, and then node, list node, and then the list node, can it be null or none? Okay, the length starts with 1. So I'll do this and then return integer, and then I'll do while, so I'll have the len L is equal 0, while node is not none. I'm gonna do node is equal node next, and then L plus equal 1, and then in the end return L, and then I'm gonna call it len for the head A, say len with double n, then L1 is equal LA, let's say LA is equal len head A, and then LB is equal len head B, and then say PTR A is equal head A, and then PTR B is equal head B, and then if LA is greater than LB, I'm gonna have while, let's say while LA greater than LB, I'm gonna have this PTR A is equal PTR A dot next, and then LA minus minus, like minus equal 1, and then while LB is greater than LA, I'm gonna have this ptrb is equal ptrb dot next, and then LB minus equal 1. And then now I have to move them simultaneously until they meet. So I have ptra while ptra not equal ptrb, I'm gonna have this ptrb is equal ptrb dot next, and then here ptra equal ptra dot next, and then I'm gonna return ptra, something like this. So first of all, I find the length of the list A, and then find the length of the list B, and then I have two pointers that are synced, and before that I have just two pointers, and then I sync those two pointers, so like they're gonna have the same length until the end node. So I sync them, and then when they are sync, I move them one at a time. Like I both move them forward and until they are not equal to each other. Or that can be so they can be an issue when there is no intersection. So in this case, or while ptra not is not none is not none, okay, or yeah, something like this. And in this case, no intersection, I should return use the key. There is no intersection. Okay, maybe I should return none in this case. Yeah, let's while this one. Interesting. So let me just print let's print it here. Print form, and then LA, and then LB. Here I'm gonna be LB. So here I'll list A 5 matching, list B should be 6 matching, and then let's say I want to print it here What's pointer A is pointing right now? PA dot val, then PB, PB dot val. Four and 6. Yeah, that's right. While none and pointers, something like this. When it was or, what was happening? I was exiting immediately. No, wait a second. So before it was or here. So what was happening? Pointer A was not why this wasn't working. So PTR A wasn't none even on the intersection, and then I needed to. So when they even met, when those pointers become equal to each other, I continued to walking until the pointer A was pointing at the end of the list. So while this one is not none and pointers not equal to each other, then I will continue. If the pointer A is none or this one equal to each other, I'm gonna exit the while loop. So the first case, it will be when I ran out of the list. So basically, pointer A is pointing to the end of the list, and or like pointers matching to each other. That means that I should exit. Yeah. Silly mistake. I wonder what's happening. Why it is this way? I guess was the way I can do just change the sign of the node, and then because the values can be negative here. Oh, like they're all positives, so I can, while working on the first list, I can change the sign, and then while working on the second list, I can like check if the value is negative, and the first time it's negative, I can return it. So I'll do something like this. While I'll have this node equals head A, and then while node is not none, I'll do node.val equals multiply equals just multiply by -1, and then I'll do this one, and then this one, and then yeah, something like this, and then node is equal head B, and then while node is equal like this, if node.val is equal -1, oh, if it's like negative less than 0, I'm gonna return node. Return none otherwise. Oh, yeah, something like this. I also need to do this node equals node.next. Okay, linked list structure was modified. So result gonna be just none, and then if node val, if res is none, I'm gonna update res is equal node, and then node is equal node is multiply equal -1, and here it return node. Return res to val. No, I cannot do this. Interesting. Cannot modify. Okay. Let's check what was done there and why my submission was such a bad one. So here head A, head B. That's pretty smart, I guess. So what does it do here? That's interesting. I didn't know that there is a solution like this. So let's say I have a different size, say 1, 2, and then here 3, 4, and then 5, and then here let's say 7. So LA gonna be head A, so it's gonna be LA, and then LB gonna be this one, LB. And then while LA not equal LB, they're not equal, so I'll do LA equals LA next, so LA moves here, and it's true. And then if LB equals LB next, okay, moving, and then they're not equals each other. Oh, yeah, they're not equals to each other. Then move again, move this one, then move this one. LA, LB's here, LB here, then move here LA, and then move here LB, and then LA moves here, and then LB moves to the none. So LB becomes none, and then next one, LA not equal LB. Okay, if LA becomes none, and then LB starts pointing on a head. So it's going to be LB here, and then LA. So next iteration, LA is none now, none, and that's gonna be pointing at head B. So it's gonna be LA here, and then I'm gonna move LB, and then I'm gonna move LA. LA gonna be here, and then LB gonna be here. Why they gonna meet anytime soon? I don't understand this one. That's very interesting solution. So solution something like this. Interesting. Okay, whatever. That's interesting, but I still don't understand it. Let's print LA and LB. Print LA, and here LA wall, and then format, and then LB, and here gonna be LB dot wall. Okay. Just LA and be known. Okay, if LA is not none, I'm gonna do just print this one part, and then LA that wall, else print LA none, and then do the same for LB. LB, and then here LB, then LB none. Let's do this one. Then Yeah. Let's do this. End is equal this one, and then end is equal this one, end is equal this one, and then end is equal this one, and then print the just empty line. So LA, LB. So initially it's gonna be 4 and 4 and what? 4 and 5. Then LA 1 and 6. Then 8 and 1. Then LA 8 and 1, and then 4. What? 8 and 1, and then 4 and 8. Yeah, 4 and 8, and then 5 and 4, and then LA 4. Oh, it's because it goes through the none. It synchronizes it, something like that. So LA none, and then LB 5, and then LA points at 5, and LB 4 points at none, and then LA points at 6, and then LB points at 4. So it's like synchronized somehow. So now they are pointing on each other, on the same, on the nodes that are the same distance from to the node where they should meet. Okay, so it's something like this. If there are like, let's say there are N1 or like L1 left, and then right distance, and then L2, then the path the first one goes gonna be L1 plus R plus L2, and then the path the second one goes gonna be L2 plus R plus L1, and they are basically equal to each other. Yeah, so like as soon as the first one reaches the end, it switches to the second one, and as soon as the second one reaches to the end, it switches to the first one. And then if they move one at a time, then they eventually gonna meet at this point. That's pretty smart one. Yeah, that's pretty smart. Okay, so that's gonna be it.